Energy. We hear a lot about energy, don't we? We'll talk about energy in terms of science. We need to talk about energy because it's a fundamental part of chemical and physical changes, and chemists are very interested in chemical and physical changes. So scientists define energy as the capacity to do work. Then you might have to ask, well, what is work? And scientists define work a little differently than we do in everyday life. Work is the action of a force through a distance. So if I push my Sharpie marker across my cart here, I just did work. I applied a force across a distance. When in everyday life we think of work as something people give you money for, right? Scientific work, action of a force through a distance, is not something you're necessarily going to get paid for. Although some people do get paid to do that. You know, here's a guy pushing a box. Are there people who get paid for pushing boxes? Yes, there are. Here he is working. He's applying a force through a distance. Pedal your bike across the street. If you even walk across the street, you're exerting a force through a distance, and that's what we define as work. We have to talk about that because energy is the capacity to do work. There are different kinds of energy. Kinetic energy is energy of motion. Potential energy is energy associated with either the position of something or with its composition. So here we have an illustration. We have a 10-kilogram weight sitting on the edge of the roof of this building. This has high potential energy because it's far above the ground. If we give that a nudge, we know what's going to happen, right? Because we've all watched cartoons. Why is it they're so fond of dangling pianos out of second-story windows in cartoons? A dangling piano above the sidewalk has a great deal of potential energy. When that rope breaks, and it always does, doesn't it? The piano comes down with a big old crash. We give this weight a nudge, and it falls. Its potential energy gets converted into kinetic energy, energy of movement. Up here, it's not moving. Now, as it's falling to the ground, it's moving very rapidly, and it has a great deal of kinetic energy. When it hits the sidewalk, now it has low energy. It's going to be a lot more stable. It's hard to fall off the ground. Some people seem to be able to do it, but it's hard to fall off the ground, right? So it's stable, and it also doesn't have any kinetic energy because it's not moving anymore. But what happened to the energy that it had? It gets transformed into another form of energy, in this case, heat. If you were to go and touch this, you might be able to discern that it's warm. And it's warm because of that impact and the transformation of the kinetic energy into heat energy. Heat energy, or thermal energy, is the energy associated with the temperature of an object. It's actually a kind of kinetic energy. What happens when you heat up, say, a solid? You know, all the particles are vibrating. You guys are, wiggling a little bit. But if we increase the temperature, then the particles move more. And so you can imagine students getting agitated. Or think about, I have a 6-year-old. When the 6-year-old has to go to the bathroom and you're in the van, right? He starts moving more, right? So that's higher thermal energy. It's a movement, but it's a movement of the particles within the substance and not a movement of the substance itself. So it's its own special kind of thermal energy. It's its own type of kinetic energy. So that's where that heat comes from. The particles in here are now moving more because of the collision between the weight and the sidewalk. We have a law relating to energy. It just tells us what happens and not why. The law of conservation of energy, energy is neither created nor destroyed. And this is important to understand. So energy can change from one form to another. If I take my Sharpie marker and demonstrate the law of gravity again, and I hold it out at shoulder height, it has potential energy. As I let it go and it falls, its potential energy decreases, but its kinetic energy increases. So we just saw potential energy turn into kinetic energy. We can also have energy flow from one object to another. If you put an ice cube in a glass of warm water, what's going to happen? The heat is going to move. The thermal energy will move from the warm water into the ice cube. The ice cube gets warmer and begins to melt. The thermal energy moves from one substance to another. And the total quantity of energy is constant. That's what conservation of energy is telling us. We know that objects that have high potential energy tend to be unstable. Chemical energy, or chemical potential energy, is a form of potential energy that arises from the interactions between the individual particles in a substance. What do you know about TNT? It explodes, right? You got to be careful with that stuff. Why does it do that? Because it has high chemical potential energy. It is unstable. And if you just give it the right little push, you get this very explosive reaction that occurs. Just like the weight on top of the building. It's not going to fall all by itself, but if you just give it that little nudge, it will. So unstable objects have high potential energy. So in physical or chemical changes, we're not talking about nuclear changes here. Energy is conserved, neither created nor destroyed. Here you have a picture of a car. So you've got molecules in the gas tank, gasoline molecules. Gasoline is unstable, right? You need to be careful with it because it can explode. And it does do controlled little explosions in your engine, and that's what causes the pistons to move, and they transfer that to the, and now I'm forgetting all the parts, but anyway, causes your car to move. So we have that chemical potential energy being transformed into kinetic energy of your car going forward. What else happens in the engine when you run the engine? Heat. The engine gets hot. Because not all of the chemical energy gets transformed into motion. Some of it gets transformed into thermal energy and just gets lost, basically. The energy of the universe is constant, but the energy of an individual system, you could lose energy to another system. So the heat energy, we might say, is lost, but it's just lost to usefulness. It's not that the energy disappeared, but it went to a form that was less useful. Systems with high potential energy tend to change in a way that lowers their potential energy. And in doing so, that energy is released into the surroundings. Any questions?